So who's never used version control before of any kind? Git or anything else? Okay. So why do we even want to do it? I take backups of my machine every night. So what's the big deal? Why would I need version control? I can always just go to a backup. You have an answer to that? Or were you just...
Well, if you mess something up and you don't know how to get back, you can go back to a previous version, so then you just don't have a bunch of code that doesn't work.
You can always go back to a previous version in the event that you should have a bunch of code that doesn't work. Not that that would ever happen to us, right? We're pros. It never happens. It happens a lot, as it turns out. And it doesn't always wait for you to take a backup before it happens. Sometimes you could be working... Okay, you have things in a working state. Then you work for a couple of hours on this new feature, and you suddenly realize you've been just going down completely the wrong path. Now you need to get back to the way it used to be when it worked. And you can't do it. So one good reason to use version control is you can always go back to previous versions if you mess something up. Another nice thing, it kind of serves as documentation. You know what you've done previously, and if you're writing good error messages, you can kind of see what you did and the order in which you did it and how you did each of those things. If we look at my GitHub for this project, on the master branch where you guys are, I have 4 commits. And I can see in order they were initial commit, add readme with day 1 homework, update the heading when the button's clicked, and update a special paragraph. I forget how I did update a special paragraph. So I click, and I see I added this line, these lines, I removed this line, and I added this line. I see exactly what I did at that step. So another nice thing, besides just being able to retrace your steps and sort of documenting things along the way, is if at some point, if you've been working on the same project for a month or so, and you're wondering, why in the heck is this line of code even there? What does it do? Maybe it did something, but it doesn't seem to be doing anything anymore. I can't tell. You can actually look through your history, find where it was added, see what that commit message was, and see it in the context in which it was originally written, and maybe make sense of it. And that will help you tell, is it still useful or not? That kind of thing. And there's a command called git blame that helps you track down which commit it was. It's called git blame, so yes, it also tells you who did it. But more importantly, it tells you which commit it's in. All kinds of good reasons to use version control. It's useful even if there's no one else on your project.
Is that enabled automatically, or do you have to turn it on?
It's as long as you're making commits, this is happening. Yep. That is how Git keeps track of your changes. If you look on the command line, you can run a command called git diff that shows you what's changed since your previous commit. So we mentioned earlier git status kind of tells you what has happened since your last commit. I have 2 new changes that have not been staged. They're changes to index.html and index.js. If I want to see what those changes were, if I want to see the difference between this and my last commit, I can say git diff. And it shows me something very much like what we saw in GitHub there. Red lines are lines that I've taken out since the last commit. Green lines are lines that I added. So I took out the H1, the button, the paragraphs, replaced it all with a form. Green lines are new. In my JavaScript, I got rid of the form, or the line that grabs the button, changed it to getting the form. Changed my function declaration, or function expression, I should say, to add the argument to the list. I prevent default now. I'm targeting the H1 instead of the paragraph. And I changed my event listener to listen for a form submission instead of a button click. So I can see exactly what changed since my last commit. And sometimes you need to do that. Sometimes you forget to commit as often as you should, and you don't even remember what all you've done since the last time you committed. If you want to see what your last commit was really quickly, without having to go out to GitHub, you can always type git log. So git log will actually show you your commit messages. So I see the last thing I did and actually committed was update a special paragraph. From here, you can hit Q to get out of the log. So how does Git actually work? We saw that there's a hidden folder called .git, right? That's where your actual repo lives. But that's a folder you never need to worry about. Git is managing that for you. So what about the folder where you're actually doing everything? That's called your working directory or your working tree. Behold. Your working directory, which is all on your machine, everything to the left of the dotted line is happening on your laptop. Your working directory is the current state of things. That's the directory where you do your work as it exists right now. Never mind any commits. That's the current state of things. Let's look at my git status again. Okay, I have changes not staged for commit. So I have 2 files that have changed in my working directory since the last time that I committed. To actually add them to the repo, we use git add. That stages them for commit. So the middle thing, the dotted tree there, that's the index or the staging area. And it has to go there before you can commit it. That tells Git to pay attention to the changes that you made since the last commit. So before you can commit, you must add. You could say git add and then a specific file, like git add index.html. Then if I did a git status, I would see changes to be committed, index.html, changes not staged for commit, index.js. So that means index.html, because I ran git add on it, is now in the middle section. It's actually in the index or the staging area. Index.js is still only in the working directory. And if I typed git commit now, I would commit one of them and not the other. Only the one that I actually added. Most of the time, we're going to run git add dot because we want to commit every change that we've made since last time. So that's the commit we're going to run most of the time, or the command we're going to run most of the time. Git add dot. Now I do a git status. Index, HTML, and JS are green, which means both have moved from the working directory to the staging area with the command add. So that means they are now in the repo. If you actually knew how to browse around the .git folder, you would find them in there. They're in there now. But we haven't given them a label. We haven't given them a way. We haven't given ourselves a way to get back to it later. But they are in there. So you could also think of commits like checkpoints. And you can interpret that word however you mean. If you want to think of it like a video game checkpoint, fine. Like you won this battle, now you could go back to that next time if you die, right? Same thing. If you die, you cannot actually go back in your Git history. But if you lose your work somehow, you can. I'm sorry, this is the real world. Death is permanent. Sorry to break it to you. But you can get back to any checkpoint that you've created, and that's effectively what you're doing when you commit. You're creating checkpoints for yourself. So let's try it. Git commit, and we know that we always want a message with our commits with -m. If you leave that off, it will launch your default text editor. Now, one of the commands I had you run in your setup was something to set VS Code as your default text editor, because otherwise it's going to be Vim. And are there any Vim users in here? Okay. If you're not a Vim user, it will confuse you to death if it just pops up unexpectedly. You can't even figure out how to exit the darn thing. Nothing works. So of course it's escape command Q, bang. I mean, duh. Yeah, so we want to change our default text editor to something else unless we are Vim power users. Vim is based on VI, which is an ancient Unix line mode editor. Okay, so git commessage -m, and what is it we actually did here? Add a form and handle submit. That's not a great message. I wish I had said change the heading when a form is submitted. I'm going to change it. You may not use this a lot, but here's how you do it. Git commit -- amend. I want to change the commit I just made. Now, if I do this, it is going to pop up my default editor. Here it is. So if you leave the -m off, this is what you're going to see anyway, and this is what you'll see if you do -- amend. So here's the commit message I had before. Not crazy about it. I'm going to say I mean, yes, that's literally what I did, but that doesn't really tell you how the thing changed. That doesn't mean anything for a user. So update heading when a form is submitted. Save that, close the file, and this should figure out that I closed it. It did. If I check out a git log now, I don't see both commits. I just see update heading when a form is submitted. Again, Q to quit this. Oh, yep. So now my changes, when I did add, moved from the working directory to the staging area or the index. When I said commit, it actually moved to the repository. The term head just refers to your most recent commit. So it's just a term that means your most recent commit the way dot means your current directory. So now that stuff is in my repository, and if I type git status now, nothing to commit, working tree clean. In other words, my working directory matches my most recent commit. No changes since then. Now it also says my branch is ahead of origin master by 1 commit. What? Everything so far is entirely on our laptops, which is still beneficial. It's still good to have your history there, but it does mean that if, for example, you're teaching someplace where you're on like a 4-foot high stage, and say you're just typing along, all of a sudden the desk falls off in such a way that your laptop ends on the bottom and the desk lands on your laptop in the middle of class, you're not going to be able to get to it if you weren't syncing it to anywhere. But thankfully, we are. Not that, I mean, hypothetically, if something like that were to happen. 15 minutes, no, half hour before the Apple Store closes, and you get there 15 minutes before it closes. Get yourself a new laptop, run back. You're back up and teaching again in no time because you did have everything saved on Git. True story. Anyway, so all that happens on your laptop. We can also add remotes, someplace to sync with. Those 2 commands that we copied and pasted out of GitHub, the first one was git remote add origin. So git remote, so any other repository that you're syncing yours with is a remote. Git remote add adds one of those things. And then you can give it a name, like origin, which is the most common. It is common if you're going to clone it from GitHub to your repo, that's what it's going to be called. So git remote add origin creates a new remote called origin. And in our case, origin is GitHub. But we could have more than one remote. If you had, if you were hosting on Heroku or something, and you wanted to be able to deploy by just pushing to that remote, you could totally add another remote called Heroku or production or whatever you wanted to call it. So to get it from your repository to the remote repository, you use the command push. So git push. And the first time, you have to tell it where you're pushing to. That's why we had git push -u origin master. Origin is the remote, master is the branch. We haven't talked about branches yet, and we may not really get to it in this class. It's a whole thing. It's important to know, but we just don't have all the time in the world. But the -u is short for -- set upstream, like this. Same exact command. And that means from now on, when I say push or pull, I'm talking about origin master. So if we want changes that are on the remote but are not on our machine yet, we do the opposite of push, which is pull. So I'll refer to this drawing when we do commits for the next little bit. Questions about that? Yeah.
So if I were to like do a bunch of separate commits and then push them, would they show up in Git as separate commits instead of just one big one?
Yep. Yep. You can make all the commits you want locally before you push, and they'll stay exactly as you did them. The only reason I push that frequently is one, because once seriously my desk fell off a stage and it landed on my laptop, and thank goodness I had been doing that. But also because it may get to the point, maybe it already has, I don't know, where you can't keep up with what I'm typing. And it's more important that you're able to follow along and understand what's happening than it is that you're able to type as fast as me. So I always push it up there so you can always see what I just committed by following the repository on GitHub. So you can always get to my code quickly because I push it up there every time I make a change, pretty much. Cool. Other questions? Yeah.
So if we're like working on different project and we want to push to a different repository, so do we need to change where to push it?
Well, you'd probably have a separate repository for that. Like you'd be in a, so your remote is tracked by what folder you're in. So if I go up a level here, I'm not in a Git repository anymore. If I go up here, I'm in a totally different repository. So if I say git push here, it's not going to go to Spellbook, it's going to go to NoteHerder. So because the .git folder is there and has its own config file that tells me what my remotes are, yeah, it's going to keep track of them separately by folder.
You can only have one Git repository in a per folder. You can't have multiple. It'll screw things up.
Yeah, you can, but it will screw things up. You sort of can. Because we sort of do it in one of ours, sort of. A subfolder. Yeah. But that can get weird. Other questions? Yeah.
This is a more general question, but what's the difference between Git and GitHub?
So Git is the actual version control system. GitHub is just a service that hosts Git repositories. There are lots of other services like GitHub. There's GitLab, there's Bitbucket, and let's see, what are some other common ones? The Source Tree or something like that. I can't remember what it's called. I think there might be one called Beanstalk. So it is just a service that lets you host remotes there. So it's just, yeah, it's a service for syncing your Git repositories. It has nothing to do with Git itself, really. So Git is the actual version control system you're using. GitHub is a service we're using to sync so that we can put our repositories in the cloud so that nothing happens if we lose our laptops. Like, say, it gets stolen in Brazil. Didn't happen to me.
Okay.
Did happen to someone else at Fretless. But he was fine. It was fine. His hard drive was encrypted, and all his work was on GitHub, so no big deal. Except for, like, you know, it was a $3,000 laptop.
It's unfortunate.
Yes, it is. Anything else? So that's a quick overview of Git. The website for today will have lots of links about it. It may not look exactly like this. This is from session 1. But some of the things we had here, three little quick overviews. One of them may make more sense to you than the other. This one, Git, the simple guide, just a simple guide for getting started with Git. No deep poop emoji. Git basics. So this is the actual documentation for Git, which may seem a little deep, but if you really want the gruesome details of the basics, here you go. This is a pretty good one. Explain it like I'm 5. So remember, if there's a topic that we just don't have that much time to dig into in class, and you want to know more, we always share links like this on the website, so be sure to check it out.